All right. This is a little bit of a tricky one to throw people off. Normally you use this idea of AX equals B. So we can see this is not really looking like that sort of format, because we've actually know the solution as X equals A to the neg 1 B. Yes, you have to use the hat trick on your calculator for this. So this is what we've really got. We've got X A neg 1 B, right? Um, so what we want to do is take this A and put it back here. So the inverse of an inverse is itself, all right? So if you take a calculator and I called it A, but when I inverse it, I get back this little matrix. So I know now that 2, 3, 3, 4, x, y equals 3 neg 1. And that's my A, x equals b, the format that we're used to. And so you can see you've got two possible equations that fall out of that. So if we do this by this to get this, we'd end up with 2x plus 3y equals 3. And if we do the other possibility of this by this to get this, we'd have 3x plus 4y equals minus 1. Do any of them look like they're on our list? It looks like 2x plus 3y equals 3. That is C. So the answer for question 6, C. All right, as often is the case with these questions, they've got a fairly simple one to start with. It says, what percentage of 200 customers are not expected to change their rating in February? So basically, if you think about it, we've got to take this T and multiply by the S and worry just about the not changing. And the not changing is P to P, G to G, and E to E. So you end up basically taking 0.2 times 40, because it's the 0.2 times the 40. If you 41, 10, 50, like so. We're doing this row by this column, but we're just worrying about the not changes. That's 0.2 times the 40, and then when we do the second one, it's going to be plus 0.3 times the middle number, which is 110, and then we do the last one, it is plus 0.3 times 50. And if you put all that in your calculator, you get 56. And so you might go, D. No, because remember the 200 customers, so you've got to divide by 200 to get 0.28, and then you got to times that by 100, do that easily in your head, and get the answer A, 28%. All right, the real key phrase here is that in the long term, you knew that was going to be coming up when you got your T's and your S naughts. So what we've got to do in this one is we've got to work out the T infinity sort of thing. And we know S infinity equals T to the power infinity times S naught, but we don't use infinity because the calculator will take forever. So we use S20 to approximate that as T to the 20. Now, if I put all those numbers in, we've got to check that we're also going from the excellent to good. That is an important part of this whole process. So if we put in our T, which I've done here, and our S here, you didn't have to actually label them. You could have just put this all straight in, but I didn't. So we put T to the power 20 times S, and we got these numbers. So that is actually 59 is the key value here. So the proportion of the excellent group changing to good. So that's excellent going to good. So excellent going to good, right? That's this number, which is 0.5. So we've got to take basically 59 and divide by 2. And, well, it actually basically equals well, if you rounded it off, 29-ish, which is why I'm a bit annoyed about this, because actually that's closest to 28. I mean, I reckon they should have put 29 as the option there, because it's much closer to 29 than it is to 28. But there you go. The answer is A for that. But the real trick was that halving.